So first, concatenating data frames. Concatenating means just combine them together, join them together. Two directions. You can concatenate two data frames vertically. Essentially, you will stack two data frames vertically like this. Okay. So in this case, of course, the two data frames should have similar columns. Otherwise, it doesn't make sense to stack them because then each column will have different variables. Okay. The function is called concat, and x is equal to 0 means concatenate along the row axis. And okay. Let's see one example. We first create two small data frames. The DFA look like this, right? 3 rows and 3 columns, ID and first name and last name. So very simple data frame. This is called DFA. And then the second data frame called DFB, it also has 3 rows and 3 columns. Okay? ID first and last. And ID have 3 different values for classes. So apparently DFA and DFB have exactly the same columns and column names. So they are kind of like two parts of a data set. Maybe one is old data set, one is new data set, a new data set. Then it makes sense to concatenate them vertically. The syntax is like this. Like the concat function is in Pandas, so don't forget to refer to the library. And then use a bracket to wrap the two data frames you want to concat together and specify the axis. And then this is the result. Again, we didn't save the result, so it will be gone after we quit Jupyter. If you want to save the result, name it, give a name, and assign it. So this is how to concatenate two data frames vertically, okay, stack them. And you can also concatenate two data frames horizontally. You just need to specify axis equals 1. That means along the columns. So our DFA and DFB have the same number of rows, 3 rows. So it's actually very convenient to concatenate them together. So Python allows it, no problem. However, you see, the result is not so good because now it is not a tidy data frame anymore because each row is not corresponding to one observation anymore. It contains information from 2 individuals and it's quite messy. It looks neat, but it's quite messy because you cannot analyze them in a good way. So instead of concatenating data frames horizontally blindly using the concat function, a better practice is to use the merge function. The merge function is similar to the different joins in the R package dplyr. So again, this is also similar to some function or commands in SQL. You will see. Let's take a look. So we first create a data frame called a df employees. It has 4 rows and 2 columns, employee ID and name, very simple. And the second data frame called df sales. So this one contains the information of employees' total sales, so employee ID and total sales. So apparently we have a main data set and a data set which provides some supplementary information. So it makes sense to merge them horizontally. To merge them, we can call the merge method function in Pandas. Just list the 2 data frames you want to merge, and then lastly specify the column that you use to do the matching work. So apparently both of DF employees and DF sales have the same column called employee ID. Naturally, this should be the column. And by default, the merge function will do an inner join. Namely, it will only contain or keep the observations with matching values in the unvariable. So in this case, only 3 and 4 are kept in the result because 5 and 6 are not contained in the employee data frame. And 1 and 2, employee 1 and 2 are not in the sales data frame. So only the observations with matching values in the employee column are kept. So this is a default behavior for the merge function. So there are 4 joins, 4 types of merges or joins in Python. So this is very similar to the join functions in dplyr. So inner join default, outer join. So this is the most generous one, which will keep everything intact. It will not delete any observations, no matter there is a matching key value or not. Left join will keep the left table complete. And right join will keep the right table complete. So these are the definitions. For example, left join is commonly used in practice because it will keep the left table complete. So usually when we do merge jobs, one table, one data frame is considered as the main data frame. And we have some metadata, some additional data frames. We want to add some more information, more columns to the main data frame. So we always want to keep the left one data frame intact, complete. We don't want to lose any information from the main data frame. Then we should use the left join. So the right table in this case will not be kept intact. Okay? Only rows with matching values in the unvariable will be retained. And the missing values will be filled if needed. Let's see some examples. So let's first do an outer join. Outer join is the most generous. You see it will not lose any information. This is the left table. A right table are employee and sales. So 3, 4, 5, 6. They are also there. Right? So it's the most generous one. If you don't want to lose any information, use an outer join. And if we use a left join, by the way, the argument is called how. If we do a left join, you see the left table is complete, but the right table is not. Employee 5 and 6 are removed because they don't have matching employee IDs. And right join will keep the right table complete. 3, 4, 5, 6 are kept in the result, but 1 and 2 are gone because the left table has 1 and 2. Don't care the left table. And lastly, sometimes when we join 2 tables, the 2 tables have different names for the matching variable. For example, let's manually change the column name of the employee ID from the original name to ID itself and call it DF sales 2. Okay, so now in DF sales 2, the employee ID is just called ID, but in the first data frame, it's still called employee ID. So now they have different names. So it's not a big problem because you have the option to specify the left on variable and right on variable. In the left table is in the DF employees table, the ID is called employee ID. So left on equals this. And in the DF sales 2 table, the ID is just called ID. It doesn't matter, right? And then let's do a left join. We get this result. And notice that there are two ID columns. It will not automatically remove the redundant column. If you want to drop it, you can just add a drop method at the end. Okay, then no repetition will be